So it wants us to find the equation of the tangent line for each of the following functions at each given value of x and draw the graph of the function and the tangent line. So I'm going to cheat and use a program to help me draw the graph of the function, but everything else I'll be doing by hand. So remember, when they only give us an x coordinate, in order to find the equation of a tangent line, we need a full point. So our step one is always to find the y value that goes with this x. So step one, we're going to find that y. So we're going to put x into our main function. So we're going to go y equals 2 times 2 squared minus 6 times 2 plus 3, which is going to be 8 minus 12 plus 3, which is going to equal negative 1. So we're going to want to keep note of that point. So our full point is x is 2, y is negative 1. We're going to be able to need that in order to find the equation of the tangent line. So remember, the tangent line we use point slope form. So we also need to find the slope. In order to find the slope of the curve, we first need to find the function that tells us the slope. Because a curve always has a different slope, we need to be able to find that function that can tell us that slope at any point we want. So we need to find the derivative of y. So y prime, so remember we're going to bring this exponent down. We're going to multiply it with the 2. So again, I will show all of the steps. 2x, 2 minus 1. Then we're going to minus 6. Remember, the derivative of just x is 1. And the derivative of a constant is just 0. So we can simplify that derivative to being 2 times 2 is 4x minus 6. So this will allow me to find the slope of my curve at any point. Specifically, we want to find it at this point because this is where our tangent line lays. So if I find the slope at this point, it's going to tell me the slope of the line coming off of that point. So step 3, we need to use our gradient function to find our slope. So we're going to sub 2 into our derivative. Because 4 times 2 is 8 minus 6 equals 2. So I have my slope 2 and negative 1. Or sorry, I have my point 2 and negative 1. And now I have my slope 2. So last but not least, we're going to now find the actual equation. So with this information, we can find our equation. Remember, our equation is always y, and we take away whatever our y value. Well, if I take away negative 1, that's the same thing as adding 1. Equals, my slope is 2, x minus 2. So this question doesn't specify what form it wants the equation in, so we can just leave it like that. We can also write it in slope-intercept form, which we need to expand that, and then we need to minus 1 from both sides. So in slope-intercept form, we have 2x. 2 times negative 2 is negative 4. Minus 1 would give us negative 5. Or we could write it in standard form, which is just again moving this y over and setting this equal to 0. So it didn't specify what it wanted, so any of these 3 answers would be completely correct. The gray, the green, or the orange. And again, to show you what that looks in graph form, so we start with our original graph. So this is the graph of 2x squared minus 6x plus 3. Now, it wanted us to find the slope of the tangent that comes off the value where x is 2. So it comes off right here. So remember, the first thing we did was find that full point. So that full point you can see is at 2 and negative 1. And it wants to know the tangent line that came off of that. So that would be this line right here. So again, if you want to kind of picture what this is, what we're trying to do here. So maybe you're a CSI person and there's, I don't know, a run over mailbox here. Somebody hit a mailbox. Let me get my pen. So here's my broken mailbox. Poor little mailbox. Kind of looks like a broken Thor's hammer. There's the little flag on the mailbox. All right. So it's over here. It's located right on this point. So you can see some tire marks, some skid marks from a car. And you want to know, did the car accidentally run it over? Or did it hit something like some ice or some oil or something and veer off and accidentally hit the mailbox? Well, you would be able to tell that from the tire tracks. If the mailbox was over here, then you could say, you made this turn perfectly, you followed the curve of the turn and you hit the mailbox. But if you're looking at this, it's like they're driving, they're making the corner, they hit that ice, makes their car go off straight, and they ran over that mailbox. So you would be able to deem, okay, this is an accident. You did apparently hit something that made your car lose control, which caused you to hit the mailbox. So that's what the tangent, that's one use of the tangent. It's if I break off the curve at this point, where's my trajectory? Where am I going to end up? So I will leave these other 3 examples for you to try and keep this one up for you to be able to see how it's worked through.